Bob Caux is doing a PhD about financial regulatory policy. Bob, what role does complexity science play in this commercial world?
Well, it plays a very important role, actually. Every day banks are interacting with each other, with the outside world. I mean, even within a day, every minute, every second, potentially trades are going on. There's a huge amount of information out there that we really struggle to capture, and it's an incredibly complex situation.
So how do you go about studying it?
So I use a technique called agent-based modelling, and what that does is it assumes that every bank is its own entity that can make its own decisions and has its own behaviour. And what we do is we create a model where all these banks can interact with each other, and then we can test what happens if we make a change to the model, say a disaster happens, how those banks will react and change their behaviours.
And what sort of insights are you getting?
Some very interesting ones, actually. What we're finding is that as things proceed in normal times, things are very stable, standard policy works very well. But actually, in stressful times, everything goes out the window, and things that you think would make sense are actually counterintuitively causing a lot of long-term issues to the system.
And what's the significance of a complexity science approach to these things?
Well, in economics, it's got a lot of significance because economic models have traditionally been quite limited. They don't look at the interactions between banks. They make a lot of assumptions. They work very well in normal times, but in 2008, with the financial crisis, we just were no longer really able to predict what's happening. Now, a complexity approach can give us another tool in the armory that allows you to sort of better understand what's going on when the real problems start.
Bob, thank you very much.
No problem, thank you.